Hello everyone. Today we will solve the problem on calculating pressure drop through an inclined pipe. So first we will see the problem clearly. The problem states water flows downward in a pipe at 45 degrees, and we will draw the schematic first. So we have an inclined pipe. And we have a point 1 here and point 2 here. To calculate the pressure drop between point 1 and 2, we are using an YouTube manometer. Okay, and this angle is 45 degrees. So this is what is given in the problem, and we are supposed to calculate the pressure drop between point 1 and point 2. Point 1 and point 2. So the manometric fluid we have is the mercury. So the dashed region represents the manometric fluid, which is mercury, and it's at an the reading in the manometric fluid shows us 6 inch. Okay, so yeah, sorry, let me put this way. The point 2 is here. We know that the YouTube manometer works on the principle of hydrostatic equilibrium. Using that, first we will calculate the pressure at the point 1 and at the point at the point 2. From the principle of hydrostatic equilibrium, we know that the pressure at point capital 1 and capital 2 are same. We will make use of that fact, and we will calculate the pressure difference between the points 1 and 2. For that, first we will write the pressure at point 1. So the water is flowing in this inclined pipe. So for point 1, so for point 1, if we calculate the pressure, it would be P1 plus the pressure whatever we have from so the pressure exerted by the fluid which is in this region, and to do that region, to calculate the pressure in that region, first we will make an assumption that the distance between this point and this point here is h, and this as x. So I repeat that the distance between the point 2 and the manometric reading in the right limb is h, and the distance between the manometric limb reading in right side and the left side, the difference between the two manometric limbs heights is given as 6 inches in the problem, and we consider that the distance between the vertical distance between the point 1 and point 2 is x. So if we look at the left hand side, the fluid which is above the manometric limb will give us a pressure on the point capital 1 here. So P1 is the pressure at point 1, and we have the water as a fluid from point 1 to, in this entire region we have the water as a fluid. So, for that we have to calculate x and we should know this distance. Okay. So, to calculate x, first we will see, we make a right angle triangle, so that x, and again in the question it is given that the distance between point 1 and 2 is 5 feet. So, I just remade the part of this channel here, which is a 5 feet distance, that is between point 1 and point 2, and we know that the angle is 45 degrees. So, if we take sine 45, it would be side opposite to theta by hypotenuse, that implies x equal to 5 times sine 45. Sorry, x equal to 5 times sine 45. So, now we know x, and we already know this distance because it is just, it is nothing but 6 inch plus h. We will just keep this as h, we do not have to calculate h, we will see that why. So, the pressure at point 1 is P equal to the pressure at point the pressure here, it is not the point 1, it is capital 1. Pressure at point capital 1 equal to pressure at point 1 plus the pressure exerted by the fluid in the region with a height of x, which would be 62.4 times 32.2 times x, where 62.4 is density of water and 32.2 is the G in FPS units, and we know that P equal to rho GH. So, this is the pressure 62.4 into 32.2 into x is the pressure exerted by the fluid in this region, which is by the fluid which is at an height of x, and then we will calculate the pressure in the remaining section in from the left hand side, and it is 62.4 times 32.2 times 6 inch. We will convert that to feet now. 1 feet equal to 12 inch. So, it is 6 by 12 feet plus h. So, it is P1 plus 62.4 times 32.2 times x plus 6 by 12 plus h, where x equal, that implies P1 plus 62.4 times 32.2 times x, we have calculated it as 5 times sine 45 plus 6 by 12 plus h. Similarly, we can calculate pressure at point capital 2. So, the point capital 2 does have two fluids above it, water, okay, we will write that. So, pressure at point 2 equal to capital 2 equal to pressure at point 2 plus pressure exerted by the fluid with an height of small h, that is water. So, we will take the density of water, which is 62.4 in FPS units, times 32.2, which is the acceleration due to gravity in FPS units, times h, plus we have the manometric fluid, the mercury for an height of 6 inch. We will write the pressure exerted by the mercury of height 6 inches. For that we need to use the properties of the mercury, which is the density. So, the density of mercury is 846 times. So, we know that the acceleration due to gravity is 32.2 times and 6 inch. The height is 6 inch, which is converted to feet, and that is 6 by 12. So, this is the pressure at point 2. And from the principle of hydrostatic equilibrium, we know that the pressure at point capital 1 is equal to pressure at capital point 2. Pressure at point capital 1 equal to pressure at point capital 2. Okay, and okay, so what we know is P1 plus 62.4 times 32.2 times 5 times sin 45 plus H plus 6 by 12. This is the pressure exerted by the fluid at point 1, which is equal to P2 plus 62.4 times 32.2 times of H plus 846 times 32.2 times 6 by 12. The LHS corresponds to the pressure exerted by fluid at point capital 1, and RHS represents the pressure exerted by the fluid water plus the pressure exerted by the mercury at point 2. So, now we need to calculate P1 minus P2, which is equal to, so yes, 32.2 times 6 by 12 times 846 minus 62.4 times, and this term gets cancelled with this term, and we will left with 62.4 times 32.2 times 5 times sin 45 degrees. This is the total pressure that we are supposed to calculate, and we have two parts here. This part of pressure drop is coming from the friction. So, this is called as the friction head, and this is coming from gravity head. Okay. And now, but the question, if you see the question clearly, it is asked to calculate the P1 minus P2 in terms of LB force per inch square. If you look at the, now we will just look at the units of this P1 minus P2. So, we have 32 minus 2, which is feet, okay, I will write it down here. 32 minus 32.2 is feet per second square times 6 by 12 is, actually it was in inches and we have converted that to feet, and 846 minus 624, these corresponds to the densities of mercury and the densities of the water. So, the density is in FPS units, it is written as LB for feet cube. So, finally, we have ended up with LB per feet times second square, but we are asked to calculate the pressure difference in terms of LB force per inch square. to get LB force per inch square from LB per feet times second square, we will multiply this with g, gravitational acceleration due to gravity, which is feet per second square, and finally we will end up with LB force per, sorry, we will divide it, not, we will divide it with feet per second square. So, we will end up with LB force per feet square. Yes, because one because 1 LB force equal to 1 LB times G. So, we already have LB here. So, we divided it with G, that is the units of G are feet per second square. So, we have got LB force per feet square. So, in this, if we in the above equation 1, if we divide 1 with G in FPS units, we will get P1 minus P2 in terms of LB force per feet square. We have said that 32.2 is the value of gravitational due to acceleration due to gravity in FPS units. So, we will have P1 minus P2 equal to 6 by 12 times 846 minus 62.4 minus 62.4 times 5 sin 45 degrees. This comes out to be 171 LB force per feet square. Yes. So, we have got P1 minus P2 as 171 LB force per feet square. But in the question, we are asked to get the pressure difference in terms of LB force per inch square, and yes, 1 feet equal to 12 inches. So, LB force per 12 square 144 times inch square, which is equivalent, which is 1.1875 LB force per inch square. So, the pressure difference P1 minus P2 that we are supposed to calculate is 1.1875 LB force per inch square. So, this is the final answer, P1 minus P2 equal to 1.1875 LB force per inch square. And later in the same question, we are asked like, what is the pressure drop due to friction only between 1 and 2 in LB force per inch square. So, here we said we have the pressure difference in the system because of friction, which is termed as friction drop. This part corresponds to the pressure drop due to friction between 1 and 2. Does the and next we are asked, does the manometer reading correspond only to friction drop? So, so P1 minus P2 due to only friction drop will be this term 6 by 12 times 846 minus 62.4. That is lb force per feet square. Does the manometer reading correspond only to friction drop? Why? No, the manometer reading corresponds to both friction drop as well as the gravitational height. Yeah, so that's about the problem.